Okay, so this lesson is about vectors and scalars. A vector is something that has magnitude and direction. Magnitude being the value and the direction pointing somewhere. So magnitude and direction. Examples of a vector include force, displacement, velocity. These all have direction associated with them. You're going to push something in a certain direction, and displacement is your overall change in position. Your velocity is your rate of motion in a certain direction. And then there's two forms of vectors that we're going to work with in here, and those are polar and rectangular vectors. Can't write very well with this pen. Polar and rectangular vectors. Polar is going to have the form r alpha, and rectangular is going to have the form some number I plus j. So we'll get to that in a minute. And also, let's define a scalar. A scalar is something that just has magnitude. It doesn't have a direction associated with it. Some examples of scalars would be time. A time measured in seconds, it doesn't have a direction associated with it. Or quantity. Quantity of any number of objects is going to be a scalar by nature. And then some physics values like distance and speed. Those are also scalars because they don't have a direction associated with them. Distance is a path. You're taking this windy path and you end up here. Your entire path is counted in the distance. Speed is what you see on your speedometer. 20, 60, 100 miles an hour. Now displacement, if we go back up here, I might travel in different directions and end up a certain length away from my origin. This dotted line here is our displacement. So it's a change in position from where we started. Okay, so let's talk about how we express polar coordinates and how we express rectangular coordinates. Polar coordinates and rectangular coordinates can both be drawn on the xy axis, and this arrow could represent some vector. Let's say that I call that vector r. Now, r could equal some length at some angle, and let's call this angle theta. We could also have a vector in a different quadrant, something down here, and this time I would actually label that angle alpha and this angle I'm still going to call theta. So I'm always going to call theta the angle that is between the normal in that quadrant, at least just for consistency in this discussion. You still have some r, or it doesn't have to be called r, it can be called anything. It could be called d. Okay. So if we write that r, the magnitude of r, equals 5, then the length of this vector is 5. And then if we say that theta equals 45 degrees, we can say that r equals 5 at 45 degrees, because the general form is going to be r theta or r alpha, depending on how you're describing it. Okay, and the other vector d, let's give that a length of, say, 4. And it's also got angle 20 degrees. This is not to scale. Okay, but we want to know alpha. So we can just add 20 to 180 degrees in this case, which gives us 200 degrees. So d equals 4 at 200 degrees. So I've just written two polar coordinates. These are polar coordinates. Sorry. Okay. Now we could also have rectangular coordinates. And rectangular coordinates are going to be composed of I and j components. And we still have the same potential to express this vector as r theta. Okay, but let's say that this is 4 and this is 5. This is going to be the I component. This is in the I direction, and this is the j component. So maybe you're used to calling it x and y. I is really the x-axis projection, and j is the y-axis projection. And we can still label this r, because the vector is going to be pointing in a straight line to a certain point in space. So we would say that r in this case is, in rectangular coordinates, it's 4i plus 5j. So now the question becomes, how do you convert between rectangular and polar? Let's go ahead and do an example. So converting from polar to rectangular. Let's convert 6 at 100 degrees to rectangular form. First, you always draw it. You could skip this step, but it's not wise. So 100 degrees is somewhere in the second quadrant. If I could get my arrow. So 100 degrees is probably something like this. So it's not going to cooperate with me right now. There we go. Which I'm going to call alpha. This is going to be theta. In this case, alpha is 100 degrees. Now there's a simple prescription for converting to rectangular, and that the main objective here is to figure out what are the I and j components. So in order to find the I components, we're going to take this length, which is 6, and multiply it by the cosine of alpha. And then we're going to also do 6 times the sine of alpha, and that's going to give us the j components. This is going to be our I component, and this is going to be our j component. So let me calculate those. The answer is that the vector r is equal to minus 1.04i plus 5.91j. Negative I value means it's going to the left. Positive j value means it's going up. This is how we convert from polar to rectangular. And the last thing is to convert between rectangular and polar. So the opposite. If our rectangular vectors are 8 and 4 or 8 and 5, we want to figure out this vector here, the resultant. Let's call that r. Well, the magnitude of r, that's going to equal the square root of 5 squared plus 8 squared because of the Pythagorean theorem, and it says that a squared plus b squared equals c squared. So that leads to this. Then we've got to say what's the angle. We need to know this angle. So theta is going to equal the inverse tangent of the j, this is j, over the I component, 8 over 5. Calculating that. After calculating, we get r is 5.9, theta is 57.996, and our vector is 5.9 at 57.996 degrees. And we just converted from rectangular to polar. There's basically 3 steps. Sum the squares and take the square root using the Pythagorean theorem. Take the inverse tangent to find theta, and write the vector as a combination of the magnitude and the direction.